Nanoparticles have dimensions of a billionth of a meter. It's hard to imagine how small that is, so I'll try to give you an idea. From this moment to this moment, your fingernails have grown about 1 nanometer. You might ask, why do we care about them if they're so small? And the fact that they are so small is exactly the reason why we should care. One of the coolest and most interesting properties of nanoparticles is that they behave in different ways according to their size. Now, if you have a golf ball, you could argue that if you make it bigger, you might end up with a football. So they're also behaving differently. But nanoparticles are much more special than that. We can get them turning from blue to red, for example, by increasing their size from 2 to 4 nanometers, which is still pretty small. In fact, if I had an ink made of nanoparticles of different sizes, all between 2 and 4 nanometers, I could probably print this entire rainbow. If you're still not impressed, even more amazing things can happen when you start to put these particles together and form bigger structures, like building things with them. It's like if you could build a statue starting from the tiniest particles of powder. You would be able to control every single small detail of it. When you do that with nanoparticles, you get very useful structures that can be used to take drugs into specific places in your body or to harvest solar energy, for example. But in order to do that, we need to understand how nanoparticles interact with each other and find ways to control these interactions. If you have a bunch of particles swimming around in a liquid, there is a good chance they will find each other and stick together, forming these big structures without particular shape or order. It's like making Turkish coffee. But we're not interested in that because they'll be a bit messy, and like for the coffee, the part that has settled at the bottom is not very useful anyway. To prevent that from happening, researchers add molecules that we call ligands to the surface of the nanoparticle. They will act like a protective layer, bumping into each other before the particles meet and sending them away. For smaller particles at lower temperatures, these ligands will change their phase behavior. It's like they freeze into these regions that move very little and can now attract each other. So instead of having the ligands preventing the particles from settling, they are now the ones causing it. This is very important because now we know that not only we can control what the particles look like individually by changing the size, but also what our structures will look like and what sort of things they'll be able to do. Yeah, no, it is quite exciting.